I'm going to start the second recording here, and what I've pulled up, I taught it in the behavioral stat class, is from the basic refresher course. It's a file VT Study 3. I actually ran this with students at Virginia Tech as part of just a classroom activity, and what we actually did, can you tell what those scales are? It's the SPSS data set.
Emotional something.
Emotional texting.
Did we talk about, there you go. Did we talk about, have we talked about burnout in here or no?
Yeah.
I thought we did.
Personal, depersonal, depressed.
So personal accomplishment, depersonalization, and depression.
Okay.
So if you're going to set up an SPSS, this particular situation, you would name these variables and then you just put in the numbers. And I ran, how many people did we have here?
I think emotional texting. That's what happens in my house.
42. So there were 42 people in this data set. Would I be interested in running correlations on this data?
Yeah, sure.
Yeah, I would be. Emotional exhaustion, personal accomplishment, depersonalization are the three subscales of burnout. And I was interested to see if they might correlate with what?
Depression.
Depression. Do you think they would?
I would think.
Yeah, if you're burned out, are you depressed?
Possibly.
You might possibly be. So in order to do that, and if you want to know the steps,
What are these numbers?
these numbers are the scores. Oh,
Off of like a survey? kind of
yes. And we have actually the survey here, so that might be useful. Let's see, how do I go back to that? I minimize this, and I minimize that. Aha! Here's the survey. It was November 7th when I covered this in a different class. This would be useful to bring up. So, it's D1 Research Survey 2, and this was the survey that I gave. The first 4 questions, emotional exhaustion, you get the score at the end. I actually gave it out to 57 people and only 42 actually added up their numbers the right way. What's that?
Too exhausted.
They were burned out. Should have used them. What's section 2 measuring? I can easily understand things, effectively deal with people. I feel very energetic.
Empowerment, or whatever the next.
Personal accomplishment. And then the third one, and I just took 4 questions out of the burnout survey. Depersonalization, and then the 4th section,
Depression.
I feel sad and depressed. Kind of a dead giveaway there. So people filled this out and we got the scores from this. So that was a highly relevant question to ask. So thank you for asking that. Let me see if I can bring this back up. So we got the scores for 42 people, and I created the columns for the 42 people, and we would want to run correlations on this. So in order to run a correlation, if you ever need to do this, and those listening in, do you think anybody's actually listening into any of these things? I don't know.
Yeah. I'm not sure yet people have, but
Maybe I need to do more comedy.
My email. So it's something I want to listen to again.
So analyze, so you go into analyze, and guess what you would go to? Correlate, and we do bivariate. I don't even know what partial and distance ones are. Bivariate, and then you put in the variables. And notice you can run different ones. Spearman, Pearson, Kendall's is for another purpose. Two-tailed. You just put them in and you run it. And then you get a screen. I think, is that on your printout, the screen? Or did I neglect to put that?
Oh yeah, no, here it is.
It's a little bit later in the equation here. So let me come back to the table because I like being near you people. So if you're ever faced with a situation where you run something on SPSS, you just can go and copy and paste that into a Word document, and people can actually look at it. Because if you look at it in SPSS, people have to have SPSS to get this. You can just grab this and then do edit, copy, and then you go to a Word file and you open it up, the Word file, and you just do paste.
Okay.
That helps a lot of people. If I do some statistics for you, I will not assume that you have SPSS and can bring it up, and this is just simpler to do it in this way.
Some of us will have it and some of us won't. So.
Sometimes you feel like a nut, and sometimes you don't. Remember that commercial? So we're kind of correlation results here. So if we look at things here, the big thing was to see if emotional exhaustion, personal accomplishment, and depersonalization were related to depression. Which column, actually everything is repeated, everything is twice, because that's just how SPSS does it. There is a way to actually say, correlate these three with this, but you don't need to know that command for now. Which column would be the column of choice, or which row would be the one?
Depressed, right?
Yeah.
That's the one
So
you're about.
you could either go with the bottom row. Let's do the right-hand column. So does it look like emotional exhaustion is correlated with depression?
Yes.
Yes.
Yes. What's the correlation number?
0.711.
0.711. What does it tell you the probability is?
0.000.
So how would you write that out?
P is less than 0.00.
There you go. Little r, and then in parentheses,
Oh.
little r, parentheses, what would go into degrees of freedom? 40. N is 42, so it's 40 here. Equals what? 0.711.
And then
P less than
P is less than
0.001. Real world statement. As emotional exhaustion increases in people, so does depression.
I have a little question. I have a hard time when I see little r's and little letters, remembering which statistical strategy goes with it. Is there like a trick? Like
cheat
correlation in Pearson
mnemonic
doesn't make
or
me think of
something.
little r's.
Don't use big R, because big R means lots of different things that are very, very complicated. Use the little r. Sometimes when there's a spearmint, I think you're right, a spearmint is written out in a slightly different way. I think it's an RHO for a spearmint correlation. But little r, you just use a little r, and that's a Pearson product correlation.
it sort of helps me remember that there's two little r's in correlation.
Thank you.
There you go.
Well,
You know how
Whatever
you can-
works.
You can look up like how to translate. I wish there was a resource, and maybe there is, of like where I could go and say, oh, little r, that means Pearson. Or
Versus when you do a T or an F
yeah,
or
a Z.
So the big thing comparing these is you got to remember that with the t-test, with a correlation, you have two continuous variables, emotional exhaustion and depression. These are both continuous variables. If it's a t result, it's got to mean one variable is categorical. Gender is a categorical variable. You could look at emotional exhaustion compared across gender, and that's a t. And if you have 3 levels of something, then that's going to be an F.
For a Nova.
For a Nova.
Yeah.
Not the grade that my students are going to get for not doing their assignments in their class. Well, that was a marginally significant joke. Not quite. Yeah, we're going over the barrel. So, yeah, that's just the way of it. Use little r. Big R means much more high-powered things. So correlations, that's kind of the nature of it, if we look at that one. And then if we go down, does it look like personal accomplishment is related to depression?
No.
No. So how would you report that?
There is not a correlation
but-
that exists between.
So you would say the real-world statement for the first one, that as emotional exhaustion goes up, so does depression. But the statistical statement, it would be R40 equals what? 0.069. Oh wait, we're marginally significant. No.
No,
No,
that's
The
not
correlation,
one to that.
the correlation is almost 0, meaning you have nothing
Yeah, your P is
there.
0.6.
And then how would you write out the P there? P is What would it be there?
Greater than.
Yep, 0.05. Bingo. There is no relationship between personal accomplishment and depression. Does it look like depersonalization is related?
Yes.
Yes. R, once again, 40 equals 0.504. And now you can write out what? P
Equals
Equals
0.001.
equals 0.001.
Hmm.
Because it gives you that. As long as it doesn't say 0. I've seen countless journal people write P equals 000. There is still a 1 in a million chance. I want to say a bunch of things here about probabilities of things happening, having to deal with federal politics, but I won't. There's a 1 in a million chance that you could have 60 straight days of above 100 degrees temperature, but the probability is so low you would say it's probably not due to chance. So go ahead.
Am I remembering that sometimes I have seen it written out where there's a moderate correlation, a high correlation? Are there sort of cutoffs for at what point you apply one of those words?
Moderate correlations and high ones, it really, that's a tough one. There isn't, I haven't seen that so much for correlations. I've seen more in t-tests that, and ANOVAs, what matters is the treatment effect. That, you know, I think in the last class I showed an example of a speed reading course that increased word reading by 3 words per minute. It was statistically significant, but you had 10,000 people, you can make anything significant.
Right.
So you have to look at not just the statistical significance, but the real world importance of things, and sometimes the treatment effect will dictate that. In a correlation, you know, that's harder to determine because you don't get correlations that are usually this high, but what is meaningful and what is not is kind of subjective in a way, I would say.
Okay.
There's no hard and fast
So
rule.
in some of the studies, the healthcare studies, when we look at different tools that they've examined, we use the terminology clinically relevant.
Yes, and
So in
that's a
other
fine
words,
term
just,
to
you know,
use.
Just because it went up, is it really meaningful? At what point does it have to go up enough to say, when this tool changed from here to here, that it really was a clinically meaningful change?
And in my field of asthma, researchers documented when I went through that a treatment effect of 0.5 on a 7-point scale was clinically meaningful. That if you have reliable and valid surveys, and they already say that if you don't get significance, that's why you don't say insignificant, you can say maybe we have a type 2 error amiss here, we didn't have enough power, and so on and so forth. But a little different with correlations to make that if somebody's made clinically significant. But the one thing I remember from the 3 terrible graduate classes I had in statistics was the professor there, and he was a really nice guy, is he said, don't let the statistical tail wag the substantive dog. Don't let the statistic tell you what something means or not. You got to look at the kind of the bigger picture on the equation.
So, for a Pearson correlation of, let's say, little r equals 0.5, does that mean, like, if 1.0 is a perfect direct correlation, does 0.5 mean, like, 50-50?
0.5 for most statisticians is considered a pretty reasonable correlation. The problem that sometimes occurs that I've seen more often than not is if you run a correlation, let's say you collect, it's very easy to give surveys out and get lots of people. And let's say you get, 1,000 people. If you get 1,000 people and you run correlations on things, you could actually get a correlation of 0.2 to be statistically significant. I've seen that a lot. And then the question is, okay, what does this really mean? Yeah, it is statistically significant, and you report it like that, but is it meaningful? 0.5 in most things that I've read does mean there is a relationship, a decent relationship. But once you get under maybe 0.4 or less, it's really a judgment call, but I've seen people get correlations of 0.2, and if you have enough people, it's significant, and it's easy to get 10,000 people with some of these, and then what have you really got there?
So what about an inverse correlation?
So inverse correlation is a negative correlation. That's just negative. It's the same game. What if I did temperature? Well, like I said before, we did what BMI and quality of life versus BMI and snoring. You'd find an inverse relationship. It's not the positive or negative, but it's the number that matters. It's the R that matters. It's not the negative or positive. The key is, how close to 0 is this? Because if your R is close to 0, there's really not much of a relationship. If you have 10,000 people and you get an R of 0.15 and it's statistically significant, you know, what have you really got there? It's a judgment
Because the
call.
inverse just has to do with which directions the variables affect
Yeah.
each
That's
other.
what
So it's not, it's just, it doesn't affect the statistics, it's
Yes.
just how you tell the story.
So the
Yeah.
other simple example of this, if we do another temperature example, temperature and ice cream cone purchases.
right.
As temperature, let's say you get 100 different, or you get a store, a Dairy Queen store, and you measure the temperature on any given day, and you get, you know, these temperatures going up. You'd find temperatures as they go up on these days. What would happen with sales?
They would go up.
As temperature goes up, so does sales on the store. What if you were to go into the Burlington coat factory and look at temperatures and parka sales?
It'd be the opposite.
It'd be an inverse negative relationship. So it's just the nature of the two variables. What matters is the actual number and how close to 1 it is. If you've got a correlation of positive 0.7 for temperature and ice cream cone purchases, and you got a correlation of negative 0.7 for temperature and parka purchases, those are the same strength.
So would it pop out of my SPSS as a negative if it's an inverse?
Yeah.
Okay.
It will. I don't think I had any of those there. Okay, so I think that kind of covers our little correlation situation. Any other questions with the correlation game of things?